Hello and welcome. My name is Brian McKay, and I'm from the Technical Marketing Group at MathWorks. Today we will talk about Raspberry Pi programming using Simulink. I'll show all the pieces of software and hardware you need and how to get it working. So the software setup. Let's talk about what we need. We need three things. First of all, we need some MathWorks software. That's MATLAB and Simulink, released 2013A or newer. And that can include the student version. However, we should note that the Raspberry Pi support is available on 32-bit and 64-bit Microsoft Windows only. We will need a compiler for the MathWorks software. In order to find one, there's a helpful link there that lists all the supported and compatible compilers for MathWorks products. For my 64-bit Windows 7 installation, I'm using a Microsoft Windows SDK 7.1, which is available at no charge. And the third thing we need is a Simulink support package for Raspberry Pi hardware. Okay, the first thing I need to do is check my MathWorks software. Remember I said you needed release 2013A or newer. I am running release 2013B, so I'm good to go. The second thing we need to check is the compiler. One way I can do that is to type this command mex-setup. This goes and looks for installed compilers. So yeah, let's go take a look. It says that I have Microsoft SDK 7.1 installed, and so that's the one I'm going to select. And yes, that's the one I want. You may need to install the compiler, but this is how you set it up. And finally, we need to get to the support package installer. There's two ways to do that. The easiest way is click Add-ons and get hardware support packages. This starts the support package installer. I almost always install from internet because this gives me the latest greatest support packages. Also note, if you ever need to uninstall a support package, that checkbox is available here. So here I'll click Next. On the left side, you'll see all the pieces of hardware that have support packages, supported by the MathWorks and a variety of products. In my case, I'm interested in Raspberry Pi right here. So here I'll just click Next. So here I'll click Login, and I can type in my password. Click Login. There's a software agreement. I click I accept, and Next. Now this lists all the third-party software that gets installed to make the Raspberry Pi work. So there are three pieces, and you can see the link for each of them as well as the license agreement. The support package installer actually goes out and grabs all of these pieces and installs it correctly for you, so you don't have to do it manually. That makes the installation go much, much faster. So right now I'll click Next and then Install. And even though the support package installation portion is complete, we still have some more setup to do. And here we click Continue to move forward with the setup tasks. Okay, first we check to make sure that we're doing the setup for the correct hardware platform. For us it's Raspberry Pi, this is correct, and we click Next. The Raspberry Pi requires firmware. This allows it to boot and operate. The support package installer provides the tools to basically go to the internet and download a Raspy and Wheezy Linux firmware image, and provides tools to write it to an SD or SD microcard on your host PC. So to move forward, we'll click Download. We need to configure the network. You can either do a local area home network, a direct connection to the host computer, or manually enter network settings. I typically pick manual, and actually I set up my own address. Now it asks us to insert the microSD or SD card into a drive into our host PC. Mine is under drive D, so I can go ahead and click Next. If you need to, refresh to find the correct drive letter. When we click right here, it's going to erase all of the information on the SD or microSD card, and it takes a bit of time to do the download and writing process. I'm going to skip ahead to the test process. Okay, we've completed the firmware step, and now we need to connect up the hardware. First thing we do is we grab the microSD or SD card from the host PC and put it in a Raspberry Pi. We connect an Ethernet cable to the Raspberry Pi and to our host PC. I do this through a USB to Ethernet adapter. And then you connect a micro USB power supply and connect that up to a USB port on your host PC or a hub. Once you do all that, give the Raspberry Pi a minute or so to boot up, and we click Next. Here we can confirm the board configuration. You can see the host name, And one really important note is if you ever forget the host name, the Raspberry Pi hardware will speak its IP address through the analog audio connector when it boots. So just plug in a set of headphones, boot the Raspberry Pi, and you'll hear the IP address that is assigned. The other thing we can do here is test a connection. So this tests the connection from our host PC to the Raspberry Pi. So I'll click that now. It says the connection successful, so everything should be set up correctly. And we can click Next. Our setup is complete. If you want to see support package examples, you can click Finish and they'll open up in a different window. With the Raspberry Pi support package, there's examples. There's things like Getting Started, which will give models and examples on how to get started, as well as examples such as image inversion. In summary, the support package installer installs all of the software elements you need to connect to and run on a Raspberry Pi, both the Simulink files as well as third-party software products. It does require a MathWorks account login, but don't worry if you don't have one. You can create one when you get to the screen. And it provides a utility to write the firmware onto an SD card. And you need to do this only on the first installation. Once you get the firmware written, you can move forward without doing it again. Okay, let's talk about the hardware setup. What hardware do we need? We need a Raspberry Pi Model B. We need a power cable. The Raspberry Pi has a micro USB connector. So I use a USB-A to micro USB-B cable for power. This lets me plug the USB cable into my host PC or a powered USB hub and provide power to my Raspberry Pi. We need an Ethernet cable to connect between the host PC and the Raspberry Pi so they can communicate with each other. We need an SD card. However, a micro SD card that sockets into an SD shell also works. Obviously, we need an open SD card port on the host computer. As we saw before, we needed that port to write the firmware onto the SD card or micro SD card. You can use a native port or a USB-based device. And we need an open Ethernet port on the host computer. A good option, especially if you have a laptop and you only have one Ethernet port that might be already used, is you can get a USB Ethernet dongle. This plugs into a USB port and gives you a second Ethernet port. We can get a case for our Raspberry Pi, which is really nice to have. And then for our examples, we need a USB webcam. You can see some of the parts in the screen capture there. The USB Ethernet dongle, my micro SD card reader, which has got a USB connection, and a micro SD card with an SD card shell. How do we hook it up? Well, we plug the USB Ethernet adapter into the host PC, and then plug in the Ethernet cable into that and the Raspberry Pi. We plug in our USB webcam into the Raspberry Pi. We insert the SD card, which in our case is a micro SD card, into the SD carrier, and we put that into the Raspberry Pi. Then we attach the USB power cable. I attach USB-A to my PC and the USB micro B to the power port on the Raspberry Pi, and we wait a minute for the Raspberry Pi to boot. So let's go test it. Okay, the first thing we should do is check to make sure our support package was installed correctly. We can do this by looking at the Simulink library, and here it is, the Simulink support package for Raspberry Pi hardware. We can also use the command line. Type in Raspberry Pi lib, and this opens the block set. You can see the blocks here. We have UDP send and receive, audio capture and playback, video capture and display, GPIO read and write. The GPIO pins are special to the Raspberry Pi and provide additional digital signal lines, as well as the LED and eSpeak text-to-speech. Remember those examples? If you lose track of where they are, you can always double-click on the blue block to get them back. Alright, the next thing we want to do is test our connection to the Raspberry Pi. I do that by using ping. Type in !ping with your IP address at the command line. This actually executes the DOS command, but from within MATLAB. If you see something like this, where you've sent 4 packets and received 4 packets and 0 were lost, that means you're connected correctly to the Raspberry Pi. So don't forget the ping command. It's really, really helpful. Finally, let's open the model that we want to run. We want to open the Raspberry Pi inversion model, and there it is. It's actually pretty simple. It's just got a video capture block, which has a device name and image size, sample time. It's got a really, really simple algorithm. and a display. So, how do we run it? Well, the first thing before we run is we check Tools, Run on Target Hardware, Options, just to make sure everything's configured correctly. We have the right target hardware, and we have the right host name, so we should be good to go. There are two ways to run the model. The first is the Deploy to Hardware button. Use this mode if you do not wish to interact with the application running on your Raspberry Pi from the host computer. However, I want to see the video display, and so therefore I do want to interact with the Raspberry Pi from my host computer. To do that, you use external mode. So you use this selection box to external mode, and in order to run in external mode, you click the Run button. This goes, it takes the drivers, gets the code, and downloads it starts it running on the Raspberry Pi. So in a couple seconds here, we're going to see some windows open up, including a display window, which will show us the inverted image. We're almost there, and there's my display window. You can see this running. I can even move the objects around, tilt up my Raspberry Pi. And this algorithm is running natively in the Raspberry Pi. It's not running on my host PC. My host PC only is showing this display. Alright, so how do we stop it? We go back to our model and click the Stop button. What about this DOS window? Well, this DOS window gives you some idea of what's going on with the model, but if you see simulation finished, you can just go ahead and close it.